Hi there, viewers. I am filming these videos to support teachers of mathematics in helping pupils make sense of mathematical ideas rather than just to follow procedures. And in this video, we're looking at sharing in a ratio, and in particular, sharing when the total is known. And this video follows my videos on sharing in a ratio when the part is known, which, as I said in that video, for me is where we should start the exploration of sharing using ratio with pupils. And the reasons for that are contained within that video. And then also, I've already done the video on sharing when the difference is known. And it doesn't really matter to me too much whether total comes before difference or difference comes before total. I filmed the difference one before the total one, so I'll reference that in this video. But it doesn't really matter which way around those go. But I think it's really crucial to start with knowing when the part is known. And so the reasons for that are in that video. So if you haven't watched that video, then I would strongly suggest you go and have a look at that one before looking at this one. So here we've got a fairly typical sharing the whole across the parts of the ratio problem. We've got the Tom and Hannah sharing £24 in the ratio 3:5. We need to work out the difference in their shares. And that's probably not where the first question that we're going to look at with this. You probably work out how much Tom has, or work out how much Hannah has, or work out how much they each get. But I've chosen this particular question to exemplify the idea to you for a reason which will become apparent later in the video. So, looking at this first sentence, Tom and Hannah share £24 in the ratio 3:5, exactly as I've done in the other videos. The first thing I would be doing here with pupils, if I was working with them, is to look at a bar model for this. And as I've said before, bar models are a great way to look at ratio, to make sense of ratio. And you can see here I've got my Cuisenaire rods up and ready, which are, or certainly can be, it's not their only use, they've got many uses, but one of their great uses is to be the physical manifestation of the bar model, to give kids an actual concrete manipulative that works alongside drawing bar models. So, first thing I would do, as I have done already, is say to kids, right, show me 3 and show me 5. Yeah, that's the ratio we've got here. Show me those values using the rods. And I would expect kids to show me those ones, not the only rods that can be used to represent 3 and 5, but certainly the smallest rods that can be used to represent both 3 and 5 simultaneously. And I expect kids to show me that. And as I always do when I start with that, looking at a ratio like that, I would say, okay, so tell me where, the basic stuff, like which one of those is Tom. Obviously, the green rod represents Tom's share in this case, because that's the 3. Which one of those is Hannah? Hannah's is the yellow rod because it's the 5 rod. She has the 5 share. And tell me about how these rods are related to each other. Tell me about these rods and the relationships contained within them. Expecting them, particularly by now, because I've done quite a bit of ratio work with them. Again, if you have seen my other 2 videos and also my ratios with fractions video, where all of this kind of starts off, then I'd expect them quite comfortably to be able to tell me things like, this is 3/5 of that, this is 5/3 of that, etc., etc. So I get that stuff going because, as I've said in my previous videos, those relationships are really, really important when it comes to linking proportion and ratio, particularly with the work in ratio and proportion that comes much later in the curriculum, when you're talking about representing that relationship algebraically, y equals kx and things like that. Being able to see those relationships is really important. And also, as I've said before, because getting kids to use the idea that one number can be turned into another number by multiplication, no matter what the number, with the exception of 0, it is a really, really crucial idea that we should be taking the time to highlight and revisit every time it comes up. And this is one of the places that comes up, the fact that we can turn 3 into 5 by multiplying by 5/3. We can turn 5 into 3 by multiplying by 3/5. And those are really crucial ideas that I think we should be taking every opportunity to reinforce and re-highlight to pupils and get kids working with and recognizing. So in this case, we've got Tom and Hannah share £24. So 24 in this represents the total amount of money. It represents all of the space, if you like, taken up by those two bars. And at this point, what we'll probably do is reorganize the bar model to look like that, because that then shows very clearly the total. Yeah, the 3 and the 5 making the 8. And this is another good reason to use Cuisenaire rods, so you can physically manipulate them before you then go and draw it. If you're going to get kids to draw such a model in their books or things like that, having the rods and being able to physically move that model around and reorganize that model to fit with the problem that we're working on is a really useful thing to be able to do. So having the physical rod's much nicer here as a starting point. So what we can see now is, okay, well, we've got the 3 and the 5 making the total of 8. And again, primary school practitioners will be very, very used to this as a part whole model. 3 plus 5 makes 8. 8 minus 5 is 3. 8 minus 3 is 5. And that 24 then that we're being given in the problem is represented by this 8. Yeah, that's the representation of the 24. That's where the 24 sits within that model. And normally, if I was on a whiteboard or something similar, I'd be drawing the 24 either next to or as part of that rod. And then I'd just say to kids, tell me about the other rods then. And as I said in my previous videos, what I try and move kids away from where I can is them telling me, oh, well, 1 square must be 3 then. And therefore that's 3, 6, 9, and that's 3, 6, 9, 12, 15. Like I say, that sort of unitary method has its place, and it's important that kids see it. And if they want to start there, it's fine. But I'd like to move them away from that eventually, because what I want to concentrate on here is the multiplicative relationships that exist directly between these values. And by that, what I mean is 2 relationships key here. The fact that 24 is 3 times bigger than 8. So the value of this rod will be 3 times 3, and the value of this rod will be 3 times 5. That's scalar relationship. But also, and crucially, like I said, for that later work, the fact that this is 3/8 of that, and this is 5/8 of that. So Tom's share is 3/8 of the total. Hannah's share is 5/8 of the total. And so then when it comes to moving that into the abstract, whether you actually just use the rods and go straight to this, or whether you get them to draw the bar model in their book, that's fine. When it comes to moving towards the abstract, we're going to use, as always, my favorite device for working with the ratio, which is the ratio table. And here I've got Tom and Hannah, and I'm going to set up their 3 to 5 shares. There's the 2 parts of the ratio we're going to see. But then, similar to what I did in the difference video, I'm going to add a 3rd column here. And that 3rd column is going to look at the total, because that 24 represents the total of the 2 parts of this ratio. And whether it's 2 parts or 3 parts makes very little difference here. If you had 3-part ratio, you'd have 3 columns, you'd add a 4th column. We'd explore those later on. And what we can see here is that total is represented by this 8 rod, or this 8 bar. And it's that total that is the £24. And again, setting it up like this allows me to highlight and allows kids to note the same key relationships between the 2 parts, between the parts and the total, and between the total in the ratio and the total amount of money. And so what we've got here, as we can see, is we've got this scalar relationship, the fact that the amount of money, as we said over here, the £24 is 3 times bigger than the 8 length of the rod. So the value of the rod is 3 times bigger than the length of the rod, and that is how these values scale up in this scenario. But what we've also got, the key crucial relationships that I highlighted before, that Hannah's share is always 5/8 of the total, reinforcing that fractional relationship within the ratio, because we ask kids to do that, right? We ask kids to take a ratio, write it as fractions. And again, my video on that, I've got a video for that if you want to look at that as well. But then we don't very often in schools use that knowledge to solve ratio problems. We go back to a unitary method. And like I say, unitary method, fine. If you absolutely must, it can be a start point. But this is where we want kids to get to, tying this knowledge together. And then similarly, we can tie in the fact that this one is 3/8 of the total. So Tom's share will always be 3/8 of the total. And again, as I've said in my other videos, this is the actual crucial relationship, because as long as that ratio is 3:5, the context and the amount of money doesn't matter. It doesn't even matter if it is money. Yeah. Anytime you have a ratio 3:5, the first part, the left-hand part, is 3/8 of the total. The right-hand part is 5/8 of the total. The left-hand part is 3/5 of the right-hand part. The right-hand part is 5/3 of the left-hand part. Yeah. And so it doesn't matter if Tom and Hannah are sharing £24 here, or whether they're sharing £1 million, or whether they're sharing, whatever it might be, that would change this scalar relationship that's at the side here. The relationship that's always going to hold true is the 5/8 and the 3/8 compared to the total, and obviously the 3/5 and the 5/3 for each part, or the 8/5 and the 8/3 if we want to go the other way and relate the total to one or other of the parts. And that's the key recognition that makes things like later on in the curriculum, the idea of proportionality being linked by y equals kx and that algebraic relationship. That's what makes this a reality, because we've seen this constant multiplying factor, this constant of proportionality. Before we start using that language, we'd normally call it a functional multiplier or an exchange rate. They've seen it used and highlighted over and over again. And when I'm giving questions to kids about ratio, I will typically pick some questions where using the scalar relationship is good, but some questions where the scalar relationship is horrible. 8 to or 7 to 16 or something like that. But where the functional relationships, the fractional relationships, are actually quite nice, halves and thirds and things like that. Okay. Now, obviously, it doesn't really matter which relationship you use to solve this problem. I want to highlight both or all three of these relationships, both types of relationship here, the scalar relationship and the functional relationship. But it doesn't actually matter which of these you use to solve the problem. Any which way you use to solve the problem, you're going to get £15 is Hannah's share. You're going to get £9 as Tom's share. And so if we want to look at the difference between those shares, the difference between their shares is going to be £6. And like I say, I probably wouldn't start that question with kids. I'd probably start with can you work out how much each of them gets, or how can you work out how much Tom gets, or how much Hannah gets, how much both get, blah, 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 etc., etc. The reason I've used this question to exemplify this is because what I'd go on to do when I see this, when we're looking at this type of question, is to say, well, actually, I don't really care how much Tom and Hannah each get here. That's not the point of this question. I want to be able to work out the difference between their shares. And I don't actually need to know their individual shares to do that. I can work it out and I can do it that way. That's fine. But what I can do here is form a relationship directly between the total and the difference. I already know the total is 8, but what's the difference between their shares? And the difference between their shares, obviously, in this case, is 2. And we can see that in the bar model as well. And if you've seen my difference video, you can see how I've shown that before. The idea that if we have the bar model like this, that we can see that physical gap, or that difference of 2 between the 2 shares. Or even if we have it set up like this, we can see it here. Look, here's Tom's share. Here's also Tom's share. Here's the difference between Tom's share. Here's the difference between Tom's share and Hannah's share. So the difference here is 2. We've got the total of 8 already. So actually, if I know the total of 8 is 24, then it's just work out the difference straight away. And that wouldn't be an issue. We could do that straight away with that problem. And so what we'll be looking at here is a relationship between the total and the difference. And we can see a couple of relationships here. Again, we can see that same scalar relationship, that because the total amount of money is 3 times bigger than the length of the bar or rod that represents it, that will be the same here. But again, obviously, that scalar relationship will change if we change the amount of money this is worth. What's key, again, in this ratio is that as long as the ratio is 3 to 5, it doesn't matter what the context is, it doesn't matter what the amount of money is, the difference will always be 1/4 of the total, or the total will be 4 times the difference if you want to work it that way around. Obviously, the numbers give you 2/8, but 2/8 simplifies to 1/4. And so again, it doesn't really matter if you're doing 2 times 3 or if you're doing 1/4 of 24. We're going to get to directly to the difference between their shares, which is 6. And I don't actually have to know how much Tom and Hannah get. And like I say, I wouldn't start out with a question like this because I'd want this table to be familiar to pupils already. So working out making the 9 and the 15 and working those out is probably the sort of first opening question, an opening step I would use here. But I definitely want to look at this question after that so that we can see that although we can use what we did before to work this out, we actually could just do that directly by finding a relationship between total and difference. So that is my shortish video on sharing with a ratio, particularly sharing when the whole is known. As always, I'd like to say a big thank you to Johnny Hall even, and his wonderful website, mathsbot.com. Can't get the things right today. It's mathsbot.com, which I use his virtual manipulatives to film all of these videos. And if you haven't seen Johnny's website, then I heartily recommend going and having a look at it. As you can see, he's got a huge number of virtual manipulatives on there for working with pupils, but that's not all that mathsbot.com has. It's got different question generators, it's got different starter things, different tasks, it's got all sorts of there. If you're a teacher and you're looking to save time with planning and resourcing your maths lessons, this is a site you definitely want to go and look at. And if you are particularly interested in looking further at using manipulatives, using representations, then I would also suggest you have a look at my own website. That's visiblemaths.co.uk. And listed on there, amongst a few other things, is my first book. I say first because there's a few of them now, but my first book, Visible Maths, which was written with that idea in mind. As you can see there, using representation and structure to enhance maths teaching in schools. So that book is entirely about using manipulatives, using representations, where they are, where they can be used well, where their pitfalls might be, the things you have to think about in order to support kids making sense of maths with representation and with manipulative. So that is the end of my video. I hope that's been useful to you, and thank you very much for your kind attention today.